CPU. The central processing unit is the main brain of the computer. Every instruction eventually passes through it, whether that is opening software, running a game, or handling background tasks. It is responsible for doing the actual thinking inside the system, taking in instructions and turning them into actions. Modern CPUs can process billions of calculations per second, and over time they evolved from simple single-core chips into complex multi-core processors that can handle many tasks at once. That shift is a big reason why modern computers feel fast and responsive even under heavy use. Motherboard. The motherboard is the main circuit board that connects everything inside the computer, and it is where all communication between components begins. It holds the CPU, RAM, storage connections, and expansion slots in a single system that allows everything to work together. The CPU and motherboard are best friends in a way because neither can really function without the other. The CPU needs the motherboard to connect to everything else and receive power and instructions, while the motherboard needs the CPU to actually bring the system to life and process anything meaningful. Over time, motherboards became more advanced, adding faster connections and more built-in features, but their core role has always stayed the same. RAM. Random access memory acts as the short-term workspace of the computer. It temporarily holds data that the system needs right now, allowing programs to open quickly and run smoothly. Unlike storage, RAM does not keep anything once the computer is turned off. The more RAM a system has, the more tasks it can handle at the same time without slowing down. This is especially important when multitasking, gaming, or working with large files where constant fast access to data is needed. GPU, the graphics processing unit, handles everything related to visuals. It renders images, animations, lighting, and effects that appear on the screen, especially in games and creative software. The GPU works alongside the CPU, but it is specialized for processing large amounts of visual data in parallel. Without a CPU, the GPU cannot function because it relies on the CPU to send instructions and manage everything the system is doing. And without the rest of the system being coordinated through the CPU, the GPU has nothing to render or respond to. In modern PCs, the GPU has become powerful enough to handle tasks far beyond graphics, including video editing and complex computations. Storage drive. The storage drive is where all data is permanently saved. This includes the operating system, applications, games, and personal files. Traditional hard drives use spinning disks to read and write data, while solid-state drives use fast electronic memory with no moving parts. SSDs significantly improve computer speed by reducing load times and making file access almost instant. Over time, storage technology shifted from focusing purely on capacity to also prioritizing speed and responsiveness.